How many of you moderate what you eat because of concerns about cholesterol? I'm sure many of you do. Cholesterol, when accumulated in your body, slowly deposits on the walls of the arteries, which might block blood flow and lead to a rupture or at its worst cause a heart attack. Scary, right? We face the same problem during oil production. In the reservoir, oil exists as a fluid. During production, as it travels from the reservoir to the surface, it experiences changes in pressure and temperature conditions. Due to these changes, certain solids separate from oil, deposit on pipe surfaces, and eventually block oil flow. Here, the worst case scenario could be a pipeline rupture caused due to deposit buildup. But what if we were able to predict when and where exactly along the pipeline such a buildup could happen? Wouldn't that save us a lot of money? That's where I come in. The purpose of my research is to predict deposit buildup caused by a component of oil called asphaltene. Asphaltenes are the heaviest fraction of crude oil. The picture above shows how severe deposit buildup in a pipeline could be. The formation of such a deposit depends upon changes in pressure, temperature, and composition of the oil. The idea here is to estimate the amount of asphaltenes that separate from oil, aggregate with each other, and deposit on pipeline walls. I achieved this by developing a comprehensive mathematical model to simulate the multi-step process taking place in the pipeline. Now, one of the challenges lies in accurately solving the equations of the model developed. So, I used computational fluid dynamics, which is a tool to numerically solve fluid flow problems with the help of high-speed computers. It helped in representing the oil flow field and the deposition mechanism better than previous work done in this area and precisely determining the amount of asphaltenes deposited on pipeline walls. One such prediction performed for a pipeline that extends from the reservoir to the oil wellhead is shown in this figure. You can see when asphaltene buildup starts, its profile along the length of the pipeline and its severity after a few years. With the help of such a prediction, oil companies would now know if there is going to be a deposit buildup and how they can strategize the production scenario for the upcoming years. They could change the operating conditions so that they wouldn't have to deal with deposit buildup conditions. So my model tells an oil company if and when it's going to face a heart attack. They can either make changes to their lifestyle now or deal with the surgery later. But remember, prevention before is always better than a treatment after, be it a problem in your artery or an oil pipeline. Thank you.